Is Moshtaq Ahmed. I'm Extension School's graduate degree program student. I'll be presenting right now my final project on exchanging data between relational databases and HDFS. In this presentation, I'll be showing my problem statement or my background of why I've chosen this topic, and my proposed tool or the tool that I developed and how the tool works, as well as I'll be giving some code analysis and way forward from where we can take this project forward. Problem statement: HDFS is a Linux-based framework and tools are available in Java platform, and Microsoft SQL Server is popular RDBMS and installed in only Windows platform. So we need a tool that can exchange data between MS SQL Server and HDFS in real time. Scope is limited to Hadoop cluster only. I don't have any programmatical access to it from a .NET developer, so I can just configure a scoop and just set up a JDBC driver and ask scoop, and scoop can do MapReduce. And I understand a lot of people already have done this exercise, so I wanted to integrate or exchange data differently. So I'm interested to use web HDFS to provide an option for interacting HDFS by using REST API, and also SQL Server data provider. I need to do some browsing of metadata so that I can read the metadata, read the table, read the database, and I can send create query and send it to HDFS by uploading the file. But to do this, SQL Server, when there is a large number of records, then we need to split those queries into sizable chunks, and those chunks needs to process asynchronously so that it is not like a big few million records we are sending at a time and overwhelming the network as well as memory and programming processor capacity. So to try this exercise, I have also created one Hive query processor that can receive the SQL table structure, converted to Hive table structure, and loaded the data which I have already exported to HDFS file. So I have given a query visualizer tool for that. For this demonstration, I used following technologies. I used Cloudera QuickStart VM version 5.4. I used Microsoft Visual Studio.NET, especially C# programming language, MS SQL Server 2008 R2, Cloudera Hive ODBC driver, Web HDFS, and Hive in Cloudera ODBC driver for Microsoft Text Query for importing data. And I was trying with NuGet Microsoft Hadoop Web HDFS library, but I could not make it 100% work, but some of the features I'm using it. So here is my architecture. In the architecture, on the top is Hadoop cluster and the bottom is SQL Server. I have two browsers. One is HDFS browser that can browse all the files and structures and the folders, and also can import and export data in the Hadoop cluster. And I can do everything by using REST API in the Windows client. RDBMS browser, that is basically reading database using SQL metadata. Then I have a data exporter which can receive a table request and create multiple queries, and sending those queries to SQL Server asynchronously. And then SQL Server also returns back like chunk of data to my data query processor. Once my data query processor receives the data, that sends to the Hadoop cluster. And eventually all the data processing jobs are viewed in the log viewer. I have also created one Hive query processor. Once I exported the data to Hive cluster, in a directory. That directory can be imported to Hive tables, and Hive tables can be queried, and that query can be downloaded as a CSV file. Those CSV file can be uploaded back to the SQL Server. So this is the way data can be exchanged from Hadoop to SQL Server, and then SQL Server back to the Hadoop cluster. In here I have an assumption that there will be large volume of data will be exporting from SQL Server to Hadoop, and Hadoop will be doing the analysis, and smaller volume will be data will come to SQL Server. So I didn't actually try to do real-time synchronization. I just kept as a file-based import-export facility. Now the component of the system. So component, this is my RDBMS data exchanger. You can see like there are 3 buttons. One is for the browser for RDBMS, and then HDFS browser. I have also live query processor, and then there is a button which if you press, then it will take all the RDBMS table to the HDFS file. So here is an example, like when you put a RDBMS browser with a connector, you just put IP address and username and password, and then it will load all the databases available in the SQL Server environment. So I've been getting those things by querying to the SQL meta access. This is the table selector. Once the RDBMS browser selects the database, then all the tables are automatically populated, and you can up and down move around your cursor, and you'll be able to see how many data inside that table. So once you select a table, then you can press export, but before pressing export we need to set up for the HDFS browser. So this is the HDFS browser. You need to provide like a IP address and port number and user ID, and then if you click on load folder, it will use the REST API and receive all the folders and populate a tree on your left, and then you can select a folder. You will be able to see all the list of files on your right hand side, and then you can select that file. You will be able to see like top few lines of content, and then it will also show you the file length. You can create a new folder by in the bottom folder name. You can just create that folder, or you can delete that folder just selecting on the left and right. You just delete the folder. You can select a file, and you can also delete the file. You can upload a file to the system. So for example, like it's like an import, upload a file. So I created a small text file, like this is my test upload. Then I select it, and then I press the button upload. It uploaded. You can see on the right hand side is uploaded. Similarly, you can see any data there, and then you can select it for download, and you can download it. So when you actually press on exchange, it will actually take all the data from table, and then create first of all it analyze like how many chunks would be needed. So I set up like 1,000 record as chunk. So if it is more than 1,000 records, then it will create multiple chunks. So in this example I was showing only 733 records, so it is showing like only one chunk of the data. So you can just pressing it, it will analyze those data and upload that file. But if you have multiple, like few thousands of records, then it will give you a lot of like data will be fetched, and then a lot of time, and then also uploaded a lot of time. Sometimes data will be fetched if your Cloudera is a remote host, if there is a network IO, and so it will be fetched and it will wait for the exporting. And on the left I was trying to row count, so as it is chunk is uploading into the FDSS file, and then both my client and server is like far from my machine, so I was actually having a bit of network issue because of VPN, so but still it was doing the job that I'm looking for. So this is the Hive query processor. Basically you can load the data, you can do everything, but you need to create a DSN. DSN is like if you can create a install Cloudera Hive, then it will give you the option, and then you just connect them. It's a simple process to create the DSN. and you can do the select query or non-query, and then you can download those data, and you can use the importer. So that's all of my system. Let's do a little bit of code analysis. On the code analysis, on the RDBMS query, you can see like I use sys databases, and I took the name and file name just to get all the database names, and also I took like table name. So from the DT properties, from the sys object, I took like DT properties and the name, where the DT properties is not the name equals DT properties, so that I was getting all the table name under the database. Similarly, to do like further query, to know the list of columns, I need table ID. So I also created another one from the table name to the table ID. And then I actually created all the columns, and then columns I put like a comma separator for heading for the CSV file that I exported to HDFS. On the HDFS client, I did like mostly like asynchronous processing, and used the JSON, and I followed this specification that was given by Cloudera. Both Cloudera and HDFS got the specification, and everything is asynchronous. And but there was a problem I was facing on the uploading and downloading on the post operation. Post operation, the reference is saying like you need to send a request, and then you get a redirected URL. That redirected URL, then you need to put the async. So I needed to do that. So it was taking a bit of time to understand how it operates. In terms of data exporter, as you can see on the left hand side, I highlighted like it's a like 1000 records as a chunk, and then I was actually running this query almost like a map reduce, and I was using a parallel for each, if you can see in the bottom, and also I was parallel for each was doing basically mapping function, and then I had a query, asynchronous SQL query to string for data export, that is like a moving to map function, reduce function. I need to do a SQL to Hive data converter. Here is the SQL to Hive data converter that is given here. Now let's go from here to the live demo. Before going to the live demo, I think like this is start of a project. It is not yet like production ready, but significant work has been done to browse the HDFS data and then also sync with the SQL tables. I think that can be further extended. And then Oracle and MySQL Server can be explored, because it's only just matter of changing the drivers. So it can be processed like same way. So all the relational database can also be even live synchronized, even if you can do some query, like if latest data is updated, the data can be shifted. There is different type of query produced, and that can be updated to HDFS.